think there's been some confusion about the ROC curve we've been talking about. We're talking about diagnosis, thinking about our true positive rate, our false positive rate. How do we optimize our decision making? When we talk about the ROC curve, that's the receiving operator characteristic. The common graph we see is this one here, where we have the 50% random classifier there, and as we get better, as it goes up to this one value. That's how a lot of people think about it. Makes sense, because as you get away from random, you get to a perfect true positive rate and a zero false positive rate, then you have the perfect test. That's what we're all striving for, although we know none of our tests are going to be anywhere close to that. If we plot ours from our studies, we can plot them here. This is what our studies look like. This is 5 separate studies of sensitivity and 1 Midas specificity values. So that gives us our true positive rate here, our false negative rate over here, false positive rate underneath. So the way we actually get a curve, though, is because we have this clinical question of a variable. So say we look at blood glucose. Okay, so let's look at blood glucose, and let's say we have 2 populations: a diseased population with diabetes, a healthy population without diabetes. We have blood glucose values for one population with one mean and another with another mean. So if we're going to test blood glucose values, how do we pick the value that will identify the patients with disease and try to keep out the patients that are healthy? So I've just made up numbers here. These are probably not accurate, but if I pick numbers, like let's say the healthy population has a mean of 85, they have a variance of 10, and the diseased population has an average blood glucose value of 105. As we select a certain cutoff point here of our blood glucose, we can select this cutoff point here, which will capture all of the healthy patients, or will only capture the disease patients. So therefore, this is our perfect test. This is very nice because we can pick 95 and have all true positives, no false positives. Great. It's nice and easy. No test is going to work like that. However, most tests are a little muddier, a little more unclear, and what we end up seeing is this dual overlapped means and some overlapped of the disease states and the healthy states. So when we have a blood glucose value of, say, 110, in this scenario, if we pick this cutoff point, we would not get all of the true positives. We would not encompass all of the true positive rate. We would only get maybe 10% here. If we do right here, this 10%. So we've only got 10% of the disease population captured because we have all this curve here which has not been identified. So we want to identify more of that curve. So we're going to move it over here. If we move it here, now we've identified at 105. If we set our lab value at 105, we've now identified half of the disease population right here. So true positives, the true positive rate is now 0.5. We found half of them. Great, good job. However, because the means overlap, we started to pick up some false positives. And so this started to move over a little bit. So we've captured this amount of false positives. That's right here. And so we end up with this point. If we keep moving it left, let's pick it at 102.5. Let's move it over here. Right at this point here, what happens? We have all of these true positives. So the true positive of 0.8, that's pretty good. We have all our false positives here. We have more false positives, however, and so it starts to move to the right. And so we have maybe 0.2. So we have like a 20% false positive rate. Now the question becomes, if you're a clinician, at what point do you pick a value to help your cutoff point. And this will come into cost, this will come into treatment options. There's a lot more that goes into this, but this is how we get this curve, because then at say 97.5, we now have almost all of our true positive, all of our disease patients, almost all of them picked up. Some of them still missed, so we're not quite at 100%. And then a lot more false positives over here. More healthy people being picked up as diseased. That's why we can kind of slide this back and forth and get all of these points along this curve here. The confusion for us is because we have hot test or EPT testing or cold testing, or the values are either positive or negative. All we can do is plot these values. So from this study, we had a positive, the EPT, had a true positive rate of 0.93, and then a false positive rate of 0.1. So that was this study. There's this study. Here's this study. We can't really infer curves from this because we don't know if the curve goes up and over. We don't know if the curve goes up and over. We don't know if it's a straight line or not. So I think the better analysis here is the 2x2s we were talking about. And we can kind of see that in this ROC curve: true positive, false negative, false positive, true negative. However, let's run some simulations with that. So if we start to run some simulations with that, this is the cold test. Let's run it with the EPT. No, this is the EPT test. I'm going to run the EPT test on the average patient. The EPT, will call it a sensitivity of 72%, specificity of 93%. The really important part here is my clinical probability of 40%. Say the average patient is 40%. However, you're going to go through your history. You're going to do clinical radiographic findings, as Dr. pointed out. And then we're going to modulate this clinical probability a bit. So let's say it's 40%, okay? If we start at this point, if we get a negative result, meaning the tooth feels the EPT, if the tooth feels EPT, if the patient says, ouch, that hurts, take it off, we are reasonably certain that we have a truly vital tooth. Only 16.7% chance of disease. However, we will, with these sensitivity and specificity values in this population clinical probability, we will miss 11 people. Kind of a high number to miss, considering there may be instances medically we need it, astronauts, military, etc., as was being discussed. There are times where we will still have a clinical treatment threshold to try to get these patients, to eliminate risk for these patients. For the standard patient, we're still very certain, pretty certain, that the tooth is vital. However, let's do cold first. So if I do the cold test next, this is the sensitivity and specificity of cold. If I have a negative result here, which means a positive cold test, if the patient feels the cold, they say, ouch, why did you do that, doc? I am 9.4% chance, they have a 9.4% chance of actually having disease. So we will have missed 5 patients out of 100 with disease. That's why we picked the cold test. This is why it's a better test for us. That's why we rely on it more. We can use it on more teeth. We can use it through restorations. This is generally why it's preferred. The big difference here comes when we change our clinical probability percent. So, and I think this is the point the group on TDO is getting at. When I take clinical history and radiographic findings into account, if I change my clinical probability that a tooth is diseased to 90%, let's just slide it to 90%. If I change it to 90%, we're going to get very different answers, okay? What that looks like. So now my cold test, now if it's negative, if I have a 90% chance of disease. If the patient still feels cold, if they say, ouch, take it off, I say, now this is confusing because I should have a 58% chance of disease. I'd look at your tooth and say, your tooth is probably still diseased. I don't know why you felt the cold, but your tooth is probably still diseased. So that's that coin flip that we're talking about, where it just leads to more confusion. Same thing with the EPT. So if I do the EPT test with the sensitivity specificity values here, if my clinical probability is 90%, if I still have a negative test, if I have a negative test, the EPT, meaning the patient feels it, I'm probably still going to recommend the root canal treatment because 73% chance of disease still remains. The test has given me a conflicting result against my clinical intuition, and that's why people advocate to eliminate the EPT. As far as I can tell, please correct me. I am more of a graphical person. I like lines and charts, and I found another website that will give me lines and charts. I do a lot better with this. And so let's just run the EPT test. This one is called a nomogram. Okay, this has a prior probability here. The likelihood ratio is based on the sensitivity, specificity, and population prevalence, or my clinical or my what did we call it? Clinical probability. Okay, and then runs that through positive and negative findings to give us our posterior probability. If I run that in a sample of 100 people, let's find out if I change my prevalence to 90. I've done my testing, or I've done my exam. I'm reasonably sure this tooth needs it, and I run my electric pulp test. If the patient feels it, if I have a negative result and the patient feels it, I still have a very high suspicion for disease in this case. It has, because my prior probability was so high, low on this chart, high, 90%, it has not changed the posterior probability very much. So it has not added to much. It's probably confused things more. If I get a positive test result, meaning the EPT meter goes all the way up to 80, patient doesn't feel it, I am very confident that I have a diseased tooth. So in summary, I think the ROC curve is not very helpful for us because we don't have continuous variable to measure against. We can't compare means. Let's just toss the idea of the ROC curve. Let's instead focus on this nomogram. For me, this is the most helpful visually to get to where I need to be. Another thing that's helpful too is also, running these numbers in our heads, running these simulations to find out, how many patients that are diseased are we actually missing? If I run the EPT test or the cold test, and if with a 50-50 chance of disease here, if I run my cold test, even with it as accurate as I think it is, like, I'm still missing 6 people, or I'm still falsely diagnosing 8 people. I think the idea to take a step back and think about our decision making, what that means for patient impact, or our diagnostic testing, and what that means for our treatment decision making and the patient impact, I think it's fun to do. So let's think about it more and talk about it more, and have a good discussion.